So I tried to give you like a nice range of questions, okay? And so for this one, you could do a couple things, right? I think you could either, add 6 to both sides right off the bat, or you could multiply the whole equation by 4 to get rid of that fraction. Either way, I think the only one you got to be cautious of a little bit is if you multiply the whole thing by 4, everything has to be multiplied by 4, right? That, and that. That's the only caution I think with this question. But if you decided to add the 6 to both sides first, that might have been the easiest, like the least number of work, or the shortest solution maybe. So you're going to have x plus 4 left, and then you're going to have is equal to negative 5 plus 6. And so x over 4 is going to equal 1, and so x is going to equal 4. Okay? It's I thought that was kind of a nice start. It had a fraction in it, but I thought it was an alright start to the quiz. This one here, before you can do any shifting or moving around of anything, I think you better get rid of these brackets on the right through expansion, okay? And so what you're going to see here, we're going to see 24x minus 20. And if I remember going too fast, just stop me, okay? And we'll talk about anything if you don't understand anything. Negative 4 times 1 is going to be negative 4, and negative 4 times negative 7 is? Okay, be careful. Yeah, it's numerically it should be 28, but just be careful with the signs, right? 2 negatives make a positive, okay? And don't forget there's an x on it, okay? So now you're in the position where you could just shuffle things around to get x's on one side and numbers on the other, right? So we're going to see 24x take away 28x is going to equal negative 4 plus 20. All right, is it okay? All I did there was create those 0 pairs. Instead of subtracting 20, I added 20 to both sides, and instead of adding 28x, I subtracted 28x from both sides. Okay. So now you've got like terms with like terms on either side of the equal sign. You could go, okay, 24 take away 28, that's going to be negative 4x. Has to equal 16. Divide both sides by negative 4. X is going to equal negative 4. All right. Do we have any questions with that one? All right. Then we'll shoot down here. I think the easiest way to deal with this one is just to find that common multiple between the denominators. So what's the first thing that both those two numbers go into? 6. Okay, so let's multiply the whole equation times 6. Okay, so that means, and I could do this, and I'll show the extra step here. I didn't do it in my solutions, but this is something I think maybe you want to show. You could go 6 times 2x divided by 3 plus 6 times x minus 4 divided by 2 has to equal 30. Okay, and then you could deal with the division if you wanted to on both these pieces. Okay, 6 divided by 3 would be 2 times 2x plus 3 x minus 4 has to equal 30. Is everybody okay with what I did there? 6 divided by 3 is 2. 6 divided by 2 is 3. Okay? And once you're there, you can just get rid of the brackets and solve for x. Okay? Get rid of the brackets via expansion. So we're going to get 4x plus 3x minus 12 is equal to 30. Okay? We're going to see add 12 to both sides. We're going to see 7x has to equal to 30 plus 12. 7x has to equal 42. Divide both sides by 7. X is going to equal 6. All right, does anybody have any issues? Do we need to zoom in? I'll make it a little bigger there. Does anybody recognize question D? There should be a few hands go up. If you don't, you might have a problem. The problem was you didn't do all the questions I recommended. This is This question here was one off the back of that extra little, like, really clear sheet. Okay? It was one of those, it was like, I don't know, it was Z, was it something on the back? Anyway. Okay, so this, nobody ever asked me about this, so I thought, okay, well, we all should be good with it. So I put it on here just to see. Okay? So I'll find out if you were good with it or not. Anyway, this question in particular is a little interesting because not only can you multiply everything by just a number, you could multiply things by the entire denominator. And we're going to tackle this in more detail, and I hope in this course, as long as we have time. It's definitely a grade 11 concept, but there's nothing wrong with multiplying both sides by 12x plus 15. Or just take the whole denominator. Well, it's the same thing. Multiply both sides by 12x plus 15. And so you're going to be left with 3 times 7x plus 13 has to equal 2 times 12x plus 15. Okay, I took this whole denominator and I multiplied both sides by the denominator. No different than if it was a number. Okay, just throw it in some brackets and multiply both sides by the denominator, whatever that denominator is. And now, just get rid of all the brackets. Right, 3 times 7 would be 21x. 3 times 13 would be plus 39. Has to equal 2 times 12 is 24x. Plus 30, sorry. Okay, and when you shuffle things around, we're going to get 21x minus 24 has to equal 30, take away 39. Okay, all I'm doing is creating those zero pairs again. Okay. I get, oops, sorry, there's an x missing. Negative 3x has to equal negative 9. Divide both sides by negative 3. X equals 3. A little tricky question. That's why I put it on there. Okay, sometimes if I tell you to do something, try it. Better to learn that lesson now while it's on a formative than, oh, I showed up to a summative and he told me to do something. I didn't do it. There you go. All right. Okay. Are we all right? If you're not, you can sit and rewatch this. It's all right. Okay. Remember some of the steps with the inverse. Okay, that's what this question's about. Forget about b for a sec. I don't really care about it because the first thing you need is the inverse. Okay, so let's find the inverse. You think back to that little list in 1.6. The inverse is we're looking for f to the minus 1 of x, right? And to get there, we said we need to, first of all, let's get rid of the function notation. We'll reintroduce y equals 1/2 x minus 1. The inverse then tells us to swap places with the x and y are going to swap places. Okay, that's your next step here. Okay. And so when I swap places, I'm going to get something like x equals 1/2 y minus 1. Okay, the catch here is though, like we never graph things in terms of x equals this. So we always graph things in terms of y equals. So then the next step is to just give me the equation so that's, well, basically re-isolate for y. And then you've now found the inverse. Okay, because we never graph anything x equals. Okay, the exception of that x equals y squared graph I showed you yesterday, but we're not going to do that in here, I don't think. Okay, so let's just resolve for y. So to resolve for y, just be careful with your shifting. Add 1 to both sides. So you're going to get x plus 1 is equal to 1/2 y. Okay, and then to get y by itself, multiply both sides by 2, right, to get rid of that fraction, right? And everything needs to be multiplied by 2. So I'm going to get 2x plus 2 is equal to y. Okay, and then I guess for formality's sake, if I ask you for the inverse, just put it back into function notation to look like this. So that it doesn't look like original. Okay, you want to signify what's the inverse and what's the original function. Okay, so just put it back into that function notation. So you got f to the minus 1. Okay. Does anybody have any ideas or questions with how to do that? Okay, there's your inverse function. Okay, and then I thought I'd give you all another attempt to. Show me some function notation and like evaluating functions with function notation. Okay, so here for this part here, f of 6 is talking about the original function f of x. Okay, so we want to find the value of the f at x function when x equals 6. So that's what we're going to do. Okay, so we're going to say, okay, f at 6 is going to equal 1/2, plug in 6 for where you see the x's, minus 1. Well, 1/2 of 6 would be 3 minus 1, so that's 2. So f at 6 is going to equal 2. Okay, that takes care of this part. Now you got to take care of the inverse part, and then just do the math that it tells you to do. All right, so let's evaluate the f at the inverse function when the inverse function is at the x value is negative 3. We're going to get 2 times negative 3 plus 2. Well, 2 times negative 3 is negative 6 plus 2 is negative 4. Okay, and the very last step, now you found both these two pieces individually, subtract the results, and then you have your answer. Okay, so we know f at 6 is going to equal, f at 6 minus f inverse of negative 3 is going to equal, 2 minus negative 4. All right, these are just the two values, f at 6, and then we're going to find this value here is this one. And just do the math. So the answer has to be 2 plus 4 is 6. Okay. Won't everybody get caught up? That pretty much marked, for our purposes, where we currently at. That kind of marked the end of that like grade 11-y kind of content that I think is manageable without any grade 10 content. Okay, and so on the back side of the formative, we got into some of like almost like grade 9 review. Okay, like solving for the equation of line, going through 2 points. Okay, which I think we did on Tuesday or something like that. Okay, so here it says determine the equation of the line that goes through those points. Well, the very first thing I see there, the equation of a line, that's what I'm going to write down, and that's what I'm going to try and build with all my pieces, right? And so I'm going to say y is equal to mx plus b. Okay, that's what I'm trying to build. And so I think their first move here, you could do this in, you could try to do this in a few ways, but I think you're going to land back in the same spot. I think you're going to have to like solve for the slope as your first step. Okay, and we discussed what slope was. M is slope, and it was, we measured it in the change in the y's over the change in the x's, which we knew as being y2 minus y1. Where you finish, subtract off where you started. That's the change, any change, delta. Okay, and we have the change in the y's divided by the change in the x's, so x2 minus x1. All right, and so just for good practice, so you don't mess this up, I like just going here, just call this one x1 and y1, and then go x2 and y2, and then just plug them in for where you see them in your little slope calculation. Okay, so I go, okay, y2, that's negative 2. So I'm just going to slide this down here. I get negative 2, take away y1 is 6 divided by the difference in the x values. Well, I know that to be negative 9 take away 3. And so when I do this, I see I get negative 8 by negative 12, which when you reduce that, the two negatives cancel, and 8 over 12 reduces to 2/3. Jonathan?
Does it matter if you, I mean, I guess it doesn't. Like if you do y1 minus y2 over x2
Nope.
minus x2, because the signs would cancel out.
So either way, this is a good question, and like sometimes I ask this question on the summative, right? Where like the question is, does it matter if we do y1 minus y2 over x1 minus x2? No, it doesn't. What does matter is if you keep these consistent. See how the ones are kind of stacked on top of one another? You can't flip-flop them around because then that's going to mess with the signs. Okay? Another way to put that is this little like, does it matter which one of these two I use? No. Another way to put that is it doesn't matter which one you call x1, y1 and x2, y2. It doesn't matter which one you call point 1 and point 2. They're interchangeable as long as you keep it consistent with the equation, okay? So stack them. The ones go in a column and the twos go in a column, okay? And then the signs take care of themselves. You can't like flip-flop, all right? So that takes care of your slope. That's m. Okay. Once you have m, this is my kind of like thing. I like writing lists of knowns and unknowns. I know m is 2/3. The only other stuff you need to fill out in this equation is y, x, and b. Right? That's the only other information that could be available to you. So you look at what's given to you in the question, and you decide that, oh, I know that because this line has to go through these 2 points, I can use either of those 2 points to help me solve for the final thing. And I don't know, I like picking the smaller numbers just so it keeps the calculations on the smaller side, just in terms of like magnitude of what I'm trying to do. So I say, okay, looks like x is equal to 3 and y is equal to 6. Everybody agree? I just picked this point here with an x and a y. Okay, so now I have all my knowns, and the only other thing I don't know and would allow me to solve for this equation would be b. Okay, so we're just going to solve for b using my like stock y equals mx plus b equation. Right, so we write that down. Okay, we're going to make our substitutions. Well, y is 6, m is 2/3, and x is 3, plus b. Well, if I look here, the 3's are in opposite numerator and denominator, so they end up like, it's 3 divided by 3, essentially. So they drop out, and you're left with just 6 is equal to 2 plus b. Solve for b by subtracting 2 from both sides. So you get 6 minus 2 is equal to b, so b is equal to 4. Okay, are you done? Please say no. It says determine the equation, not all the components of the equation. It says give me the equation, so you better write down what the equation is. Y equals 2/3 x plus 4. That's your good. Alrighty? Anybody have any questions, comments, or concerns? Anything there? Okay. All right, the last one, not the last one, second last one. Converting from y equals mx plus b. I thought this was an interesting question just to test your little like, I had it standard form to y equals mx plus b, but that's not really interesting because then I don't test you on those little standard form rules, right? So just like be careful with this one. Okay, we have something in y equals mx plus b. We have 2 rules for standard form. No fractions. And a not negative. Okay, that's it. Okay, and remember standard form takes the form ax plus be y plus c equals 0. That's what I'm trying to build. Okay, so we're just basically trying to shift everything I have in my equation onto one side, and then nothing on the other side, which is where that 0 comes from. Okay, so that's what we're going to do. If it was me, I'd get rid of the fractions right from the very get-go because it says no fractions. There's no fractions allowed for standard form. So let's just get rid of them. How do we get rid of fractions? Yes?
Multiply them by the common denominator.
Yeah, so let's multiply them by, what's the common denominator for this one, Matthew? 10? So let's just multiply everything by 10. That looks like 16. 10. All right? Don't multiply by 16, that won't help you. All right, so everything multiplied by 10 is going to be, well, I'll write an extra line here. Again, you might not need to do this. Okay, 10y will equal 5x minus 6. Okay, now you could be, like I say, there's a smart way and a silly way to do it, but I would just, again, we've talked about the minimization of the amounts of movement that goes on across an equal sign, just so we decrease the risk of making a sign error. The less times we shift things across an equal sign, the less likely it is that we make a sign error. So if I could get everything onto one side with just one shift, I would prefer to do that than have to do two shifts. And so I would not necessarily want to, not that it doesn't matter, but I don't necessarily want to shift two things when I can just shift one. Okay, and so when I move the 10y from the left to the right, I do that by creating a zero pair, or the opposite, right? And so to do that, we subtract 10y. So we're going to get 0 is equal to 5x. And because I know it has to go x, y, and then the c term, I'm just going to slot it in there like that. And that's my answer. Okay. 3 minutes. Can I get it done in 3 minutes? All right. This question here. Let's solve for, or let's plot the bottom graph first. Okay, and then we'll plot the top equation. Okay. Bottom equation, y equals mx plus b, not too bad. I know we start at a y-intercept of -5. That's 1, 2, 3, 4, 5 right here. And then my slope tells me to go up to right 1. And so from my starting value, I go up to right 1, up to right 1, up to right 1. Okay, the opposite of that would be to go down to left 1 in case you needed to. All right, so there's one. Okay, and don't forget, there's some stuff we got to put on here. Don't forget the label. Okay, and some other stuff missing, and it is the axis labels. Okay, I typically early on in a course I'll like take half a mark off, but by the end, like every time you do it, you'll probably lose half a mark. Okay, by the end of the course, like on the exam, say. Okay, so don't forget to label this stuff, x and y. Okay, and then your other graph, okay, we can use, you could switch this into y equals mx plus b, but I said using the most appropriate method. We've discussed a few times, like there is the likelihood, again, like the last question, to make a sign error and then your line is off because you've got the wrong slope in there, the wrong y-intercept because of a sign error. So again, let's maybe not shift things around here. Let's use our x-y-intercept method to solve for the two intercepts, and then once you have 2 points, you can connect them and you've got your line. Right, so maybe for this one, I'll do this one in red so we can see. Okay, we know if I plug in 0 for x, it's going to delete it, and so I can find the y-intercept. So the y-intercept is going to be 4y is equal to 10, so y is going to equal 2.5. And so our point is actually going to be 0 and 2.5. Okay, so 0 and 2.5 is right here. And then I just do the exact opposite to find the x-intercept. I plug in y equals 0. Well, if I plug in y equals 0, now I just have 2x minus 10 equals 0. 2x is equal to 10. So x is going to equal 5. And so my x-intercept is 5, 0. So you go plot that one. 1, 2, 3, 4, 5. Okay, connect those. Okay. This is the line 2x plus 4y is minus 10 equals 0. Your point of intersection will be right here at 3, 1. Make sure, one final thing before you go, don't leave it 3, 1. That means absolutely nothing to me. That looks like two numbers separated by comma. Parentheses, please. Brackets. That's a now coordinate point. Okay? Go for break, and we'll do this other question after.